All right, so we're here going to attempt this example. I have a student on the line that's going to help me out and guide me through it, or I'm going to do that for him. So we look at this series. The first thing that you tried was what? You tried to take
The nth term test.
nth term test, good. And what was the problem with that?
It was zero. Limit was zero.
And what does that mean if the limit of a sub n goes to infinity, it becomes zero? What does that tell you?
Nothing about
Not,
the series.
yeah, you have to try something else, right? It's inconclusive. So then you
Yeah.
recognize this to be an integral. This is an arctangent integral if you were to do it. So you can do the integral test, right? Is what you told me a second ago.
Yeah. Integral test.
And what were the three conditions for integral tests?
If it's decreasing, continuous. What's the last one?
And positive was the last one.
Yeah.
Good. So of these three, you only have to prove decreasing. Do you remember how to prove something is decreasing?
You can take the derivative.
Good. If you take the derivative of the sequence, what must it be?
Has to be less than zero.
Good. So if it's less than zero for all n, then you can say it's decreasing. So when we take the derivative of this over here, we're going to get, first let's rewrite it, bring it up to the top. Use the chain rule, bring that down in front. -1, rewrite your expression. Am I done? What's left for the chain
No,
rule?
you got to take the inside.
Good. Derivative of the inside is going to be
2n.
2n. Good job. So then this negative exponent comes back down, becomes positive, and then we have -2n over n squared plus 4 squared. So can I say that this is less than 0 for all n?
Yeah.
Yes, because what is the domain of n? What are we plugging in?
Playing 1 to infinity.
Good, the natural numbers. So less than 0 for all n, that's an element of the natural numbers. Okay? The other way you could have done it, quick side note, is a proof. If you were to compare n squared plus 4 and n plus 1 squared plus 4, which one of these is greater? The one on the left or the right?
The one on the right.
And then if I take the reciprocal of both sides, what happens to the inequality?
It switches
It switches. So then
because now it's getting greater.
so now what you've said is the original term is always larger than the next term. So that by definition is decreasing. Okay, either way you want to do it. Now we take a function, let's make a function out of this thing. And it's going to be an integral from 1 to infinity of 1 or dx over x squared plus 4. So do you remember the formula for the arctangent of this thing?
Yeah, it's gonna be a 1/2 arctangent x over 2.
Good. So the general formula for this would be this right here. If you have integral of du over a squared plus, or u squared plus a squared, it's 1 over a arctangent u over a. So if you plug into that, then you will get what this student just said. So it'd be, let's go ahead and, do you see that I did the limit? Don't forget this is an improper integral. You have to do that limit step because you can't have an undefined number in a defined integral. Okay? So don't forget the limit step. And keep rewriting the limit all the way down. And that's 1 over, 2 arctangent x over 2 plus c. Nope, not plus c. Why isn't it plus c? Why is it?
I'm not really sure, but I know it's not. You don't use plus c, but I'm not sure why.
Because of the bounds. There are bounds. Anytime there are bounds, you don't use plus c on your integral. It's only if it looks like this and there's no bounds here and here,
Oh yeah.
that's when you use plus c. So this one has to be evaluated between b and a. Or actually, sorry, b and 2. Nope. Why do I have an a there? That a should be a 1, right? And then
Yep. One to t.
t or a or some constant. I chose b. Doesn't matter what your constant is. So now if we continue and plug in, I'm going to change to white, that way it doesn't blend in. We're going to have limit, and we're going to have 1/2 arc tangent you always plug in the top bound minus the bottom bound plugged in. Okay, so what would happen now?
Now you just for the one that has the variable b, you know that that arctan, the limit of it is to pi over 2.
Good.
Just arctan x.
Good, because we're going to get arctan of infinity over 2, which is still infinity, which you're saying that becomes pi over 2. Good. And then the right side, what happens to that? Do we know, is 1/2 one of the main angles that we deal with, reference angles? Do we know
Yeah.
it? Do we know an angle that has a tangent of 1/2? Not really. I mean, we deal with these main reference angles, right? So if you were to come up with your chart, none of these divide to give you 1/2. Oops, there should be a 4, 3, 2, 1, 0. Do you understand what I mean by that? So if you
Yeah.
look at this chart, this is sine then cosine for the first quadrant, basically. And it's all over 2. And then to get tangent, you divide these. And when you divide these, none of these will give you 1/2. So it's not going to be one of those main angles. It is something that you can get on your calculator, okay? But it's just not going to be something that you're going to know offhand without a calculator, is what I'm saying. So what you do at that point is you just use a little logic, and you know the integral test states what? It states that if you get a finite answer, does your series converge or diverge?
Converge.
Good. So here you need pi over 4 minus some number that you can get on your calculator. Actually have a calculator handy here. Let's see what we get when we plug in. So making sure we're in the right mode here, degrees, we would need to be in radians, probably, yes. And then you would do arctan of, where's my second function? 0.5, and you get, oh, I guess I was in degrees mode, but this is a different calculator than I'm used to, so I'm trying to find how to switch to radians. There we are. So let's try that again. So second tangent of 0.5 Gives you 0.4636 in radians. So that times 0.5 gives you 0.23. Either way, the point is that we're going to get some finite number. Hopefully on the test they'll give you, I made this problem up. I could have started this series at 2, and if I would have done that, then this would have been arctangent of 1, and then that would have given you pi over 4 over here. So either way, as long as you get a finite number, you're right. Converges. Don't forget to write what test, okay? Integral test. Any questions?
Nope.
All right, let's try another one.